For the squat section, we will be using both the spreadsheet in our Exam 1 review data listed as squats, as well as these output tables to answer our questions. So below are the results for a Shapiro-Wilk test for the squat 1RM data split by sport, which we can see cycling, rowing, and mountain running each have their own result. What can you conclude based on the information provided in the output? So a Shapiro-Wilk test is a test of normality, as we can see here. So we're trying to assess if the sample distribution of each of these sports is considered normal in relation to our population. Whenever we have a p-value greater than 0.05, that indicates that we accept the null hypothesis. The null hypothesis for the Shapiro-Wilk test is that the sample distribution is normally distributed. So we can see that each of our p-values is greater than 0.05. So we might say that each p-value is greater than 0.05. So the sample distributions for the cycling, that one was 0.175. Rowing, and mountain running, p equal to 0.390 are normally distributed. Okay, so that's what we get from this table. Next, we have a table of descriptive statistics for our experience, max knee flexion, and squat 1RM variables for each of our sports. Our question 28 is asking which sport has the highest mean max knee flexion angle. So we could look at this table at the means. Max knee flexion angle is our center column. Cycling has a mean of 97.23, rowing 98.08, and mountain running 97.51. Based on these calculations, rowing would have the highest mean max knee flexion angle. What is the sample standard deviation of experience for the rowers? So we could go to our experience column, standard deviation would be listed there, and it's 1.28. So this question is kind of an example of an output question I could give you. Alternatively, I could also ask you to do the same calculations in Excel using Excel functions. The final question in the review is asking us for the estimated percentile for a mountain runner that can squat 122% of his body weight. So there's a couple of ways we could approach this. We could go into our Excel spreadsheet and calculate the mean and standard deviation for mountain runners, specifically for squat values, since that's the percentile we're looking at. Or we could use this table, squat 1RM, and we have our mean and standard deviation values for mountain runners down here. So I'm just going to copy those and paste them into my spreadsheet. Since I'm looking for an estimated percentile, I'm calculating a z-score. which we've already done an example of in this series of videos. So I take my raw score of interest, 122, subtract the mean, divide by the standard deviation. This gives me a z-score of negative 0.56, which I can look up on my z-table. So here's my 0.06 column, and I'm at negative 0.56. So the probability is 0.2877 or 28.77%. And that would be the answer for that question.